I got to give you one example of an irrational factor that we can easily construct. So we start with a line segment, we bisect it, we draw the perpendicular bisector, and then we just put the point of the compass here and the pencil or chalk here and swing an arc around here, and we get a segment perpendicular to the original line of half its length. And if we then use that as a basis for forming a triangle, we have a right triangle. Okay? Now, whatever this distance is, we'll just call this L for the length of a line segment. It's not the length of original line segment, but we do have a line segment, and it has some length that we'll call L. Okay? Well, then this one also has length L. And by the Pythagorean theorem, the length of this segment is the square root of 2 multiplied by L. Okay? And the square root of 2 is an irrational number. Meaning that it's not one of these. Okay? So that means, among other things, it's not rational with the denominator of 2 to the n. And all these here, unless you've come up with other possibilities for the list, are rational with denominator 2 to the n. And the 2 to the n comes about simply because you're always subdividing by factor 2 using your geometric construction. But you can geometrically construct a triangle where the hypotenuse can be proven to be irrational, and that's an irrational multiple of the length of the two legs. That's a proof that you should understand. If you start by assuming that this is P over Q times the length of this, where P over Q is in lowest terms, you arrive at a contradiction. And the Greeks knew that. Greeks had figured that out thousands of years ago. And it kind of blew their minds. Okay, it was very, very disconcerting to them. Okay, so there might be other triangles where you could do this same sort of thing. So there might be other factors. Now, we also then say that we can obviously then construct n times the square root of 2, because we can just construct a line by just adding this length to this length to this length. And there are many others. Many other multiples of square root of 2 would be geometrically constructible. I haven't addressed pi. Okay, well, we'll go on with what you can do, at least with this list. We're not going to worry too much about this list, but it does exist, and there are constructible lengths that aren't on this list.